This is a little long one, just because the work already published, so it's a similar kind of topic and the title, but I changed it a little to just put AlignRT in the line. So it is an ongoing question to treat certain pelvic patient, use prone or supine position, and which one is better? I think this question being asked, it's over 10 years in all different research to do on this topic to see which one is better. In addition to the dosimetry difference, and we say, the prone, you have prone board, you can push the small ball away. So other than those kind of benefits, and we think the intra and interfractional body motion can play an important role in this debate. So usually in this kind of interfractional body motion, we have the target and the target move and the organ at risk move both. So, and all those correlations can be very important to consider which position you want to use to treat certain patients. And supine versus prone, you can alter the relative position, relative geometry in the pelvic region, and for both target and OARs. And then this will affect, and you have a perfect treatment plan, but how real this plan, how you can totally achieve the quality of the treatment plan, the supine and the prone can have different kind of effect on those. The supine versus prone position have the implications on the how much exactly the patient will move day to day and the organ at risk and the target, or moment to moment. So in this will change, the whole plan. Usually for this research, we talked about intrafractional motion. So intrafractional motion, usually there's two components. One is the patient body motion. So just like how stable the patient can maintain on the treatment table. And the other one is independently from body motion. We assume the patient may remain very stable, but internal organ and the target and organ at risk, they can move without patient body motion. So there's two components. But usually we consider this internal organ move is not much, but the patient can move wildly on the couch. So we have experienced sometimes, the patient can just cough. It can go to 2 centimeters movement. And so we consider the body motion, patient body motion, has the greatest potential and is negatively affect the treatment quality and how well you can get the achievement of your treatment plan. And supine versus prone is likely, it's very important, can have the implication how stable the patient can maintain the position during the treatment. So for different patients, maybe supine is better. For the other patients, the prone is more stable. So our study is just focused on that. So the whole thing is boiled down from the intrafractional motion for body and the internal organ movements is harder to track, but you use surface imaging, we can track the patient body motion. So this is mainly this research focus on. So for answering the question of the treating patients supine or prone, there are a lot of research, and the publications focused on people using the electroportal imaging and exact track system. Those studies are shed very valuable lights on answering this question. But the thing is, for those two methods, we are focusing on the bony anatomy. And because of this, there's some limitations of the both method. So we can only take the portal or the exact track, a single snapshot at a specific time. It's not continuous tracking. So you only know at those moments what's the body position. And because both of the methods deliver the dose, so the number of images acquired will be limited due to manage the patient dose. In our study, we use the AlignRT approach. We're using those 3D continuously body position tracking. The advantages of using the surface imaging is obviously there's no radiation dose. You can tracking the entire treatment. And the second is the availability of the whole 3D surface information. You can choose a region of interest. Within the whole region of interest, you can have 6-degree freedom data and the translation and the rotation together. And it's most of the other techniques, they can either use, just take a snapshot, or you have some different several marker positions. So it's not like the whole surface. The other good part is the continuous tracking. I can track the patient during the entire treatment. So either 10 minutes or 1 hour, you can have the continuous patient body position. So in this study, and we have 10 patients with the pelvic treatment, either gynecologic or gastrointestinal and the malignancy. So for the 10 patients, and we treated 6 patients in supine position, 4 in prone position. The median age of those patients are 60, it's a little on higher end, and the range from 28 to 85. The medium height is 165.6 cm, and we have a large range again. And the patient weight is 153 pounds, and range from 99 to 211. So it's not extremely large, but over 200, it's a larger patient. The median body mass index is 25.1, so range from 19.7 to 32.1. 32.1 is on a pretty high end already. This study is IRB approved, so for every single patient, we have 2 helical CT simulation scan, 1 in prone position, 1 in supine position. In the supine position, the patient is immobilized in the alpha cradle. For the prone position, patient immobilized use the belly board. So after both scan done the same day, and after the scan done, and we transfer all those CT images to treatment planning system, we use Eclipse. And then the body contour generated in Eclipse, we transfer those body contours to AlignRT, used as the reference image for both supine prone position for the same patient. So during the treatment day, the first, we align patient use the real treatment position. For example, if it's supine, we align the patient in the room, use a skin marker. We have 3 tattoos, so on the patient body, and we use that, align the laser. So after the alignment, we will use the AlignRT tracking, and just track 1.5 to 2 minutes patient body motion. Actually, this study, we have more parts, and I just didn't include that in our study. It's the original study designed with, we use CT on rail. We have CT on rail, and this AlignRT in the same treatment walls. So I actually find the result from the CT on rail and AlignRT pretty similar. But for this talk, I will just focus on the AlignRT part. So after we treat the patient, use the designed treatment position, and then we will flip. So for example, if we use supine, we will flip the patient to the prone position, and then the same, align the patient to skin marker and room laser. So during the CT simulation, we have 2 sites of the markers, and we know where to align. So after that, the same way, we will do the AlignRT tracking and 1.5 to 2 minutes. So the exactly same way as the treatment position. So for each patient, we do 1 week this kind of recording for both supine and prone. Supine and prone use the same day. So, and each patient 1 week. So usually those treatment is 5 weeks treatment. So for each patient, I have 10 total tracking, 5 for supine, 5 for prone. AlignRT gave 6 degrees of freedom data. So we have the translation, lateral, longitudinal, vertical, and pitch, yaw, row. So for comparison purpose, and we would like to want to know what is the equivalent translation, then we can compare different position. So by using the rigid body equivalent translation, and here are the equations. Will be the lateral direction. This is the longitudinal. This is the vertical. So by applying this 6-degree data to those, and we can boil down every single time point, the equivalent translation. We process the data, and we have the maximum equivalent body motion along the vertical, longitudinal, and lateral direction, and the standard deviation of the equivalent body motion. So using the maximum equivalent body motion, it's a kind of represent the magnitude of the body motion from negative to positive, and you know how much the range the patient move. For the standard deviation, it's a sort of measure of the amplitude of the continuously body move. So it's larger deviation means you have the body motion more and constantly, and small means it's very low. Just is a measure of that. And after we get the maximum and the standard deviation of those motion, we average for every single patient over the 5 fractions. And to average, it's just boil down all those numbers to a single number. It's easy to compare. And at the same time, we watched if the patient, every single fraction is consistent, like supine is always better than prone, prone is always better than supine. So we watch the consistent of that also. And for the results, we noticed the motion amplitude along the lateral direction much smaller than along the vertical and the longitudinal direction. So the maximum movement, I think, is along the longitudinal for the whole study is approached to 3 centimeters. But for the laterally, it's much smaller than that. And it's about the average maximum equivalent lateral motion for all 10 patients is 2.4 millimeters in supine position and 3.5 millimeter in prone position. So it's pretty small. And within this 2 number, and it's no significant difference between supine and prone. So in the later kind of data process analysis, I exclude the lateral direction. It's a little small, but I have to squeeze out the data in one table, and I apologize for small number. And I color-coded. So when you see the right color, so means it's the supine position, the motion, average motion, it's bigger. And for the blue color, it's the prone position, the patient motion is bigger. And there's one black. That black is one direction, the supine is better, and one direction, the prone is better. So this is just the 10 patients sorted with the BMI number from the lowest to the highest. So, and for the average here, this one is probably the highest number, 16. Yeah, 16.5. This is the average. So this is not the absolute highest. So for some patients, you can see the prone position can be very high body motion along the longitudinal direction. This table is just calculate the difference between supine and prone, make it easy to read. So it's just a simple math of this. Oh, let me get back. It's just a simple math just deduct this from that. So, and you can see there are 3 red, and that red means the patient move more supine, and all the other blue means the patient move more prone, and the black one is still, it's a little ambiguous. So the positive number always just means the patient motion larger for supine position, and the negative number means the patient motion larger for prone position. And very simple, the preferred treatment position defined as the minimal patient body motion. So you can see here. So the red color, and we will prefer treatment patient prone, and the other treat the patient supine. And since this one is the 2 directions are different, so we can say either supine or prone. It's no big difference. So for all the 10 patients, we can further divide them into 2 groups based on the obesity society criterion, and we say some patients within normal BMI range, some patients are obese, overweight. So you can see for this cut line is about BMI 25. So the patient here, the first 6 patients are within the normal BMI range. 7, 8, 9, 10 are the overweighted, obese patients. So we divide them to 2 groups. The very important result in this study is we observed the correlation between the patient motion and the patient a large BMI. So for the overweight patient, and all the 4 patients, the intrafractional body motion smaller for supine position, both along the vertical and longitudinal directions. And this statistically significant of all those data. And we can go back to the table to see, and 7, 8, 9, 10, all those 4 patients, you can see they are all blue, and the blue color is color-coded, and just you can see all is the supine. The kind of, the number is a little bigger. And for this one, it's clear. So you can see they're all negative numbers. So it means the patient motion and is larger for prone position. And this is the typical AlignRT tracking data for the patient, for the obese patient. And this is the BMI, patient BMI is 29.2. And I put both the vertical and the longitudinal. And this is supine, this is prone. So you can see very clear, and so they're the same scale, and same timeline. So you can see very clear. So especially for this and the vertical, I think this one picture better than 1,000 words. So you can see this AlignRT can give you clearly which position is patient can maintain the body position better. So for normal BMI range patient, there is no clear advantages of either supine or prone position. And we will go back to the table next slides. In it's 1 to 5, those patients are supine larger than prone. And patient 3 and 6 is prone larger than supine. And there's one patient along vertical direction, prone is larger than supine, and on longitudinal, supine larger than prone. So it's a little more complicated. So, and we go to the table, we can see 1, 2, let's see, 1, 2, this 5, they are in the red color, so it's the supine. So, and we can go here, this one is better. So you can see this group, 1 to 5, and 3, 6, and number 4. So in there's no clear advantages which one I switch. But we can see clearly it's highly patient-dependent, but I'm going to show you a tracing. So for this is a patient number 5 and normal BMI. You can see the supine position, all 3 directions. The patient has more motion in the supine position compared to prone. So it can be pretty clear to say the patient should be treated in prone position. And for the same normal BMI patient group, this patient is the opposite. You can see all 3 directions. You can see how big the prone position patient movement, and the supine is much less. So this is the beauty of this study. And when I saw those graphs, I was pretty shocked. It's pretty consistent. For patient 5 weeks, if the same patient, almost all 5 weeks, the graph is like this. It's not like 1 week prone is better, 1 week supine is better. So if the patient, and it's not like if the patient panic, if the patient very stable in stable stage, you put the patient to different position, there is one. Usually for most patients, for 9 of my 10 patients, it's clear you can see one position, patient has less motion than the other. So for large BMI patient, preferred treatment position is supine other than prone. This is reasonable. We can think of for the overweight, obese patient. Most of those patients, have big belly. So you imagine you laid, prone on the table on a belly board and on those huge belly. What would happen? So of course it's not comfortable, and for them prone to start the body motion. And for the tracing, we can see it's not like the abrupt move, it's constant move. They're just not comfortable. For this study, we can see for the tracing I showed, and you can see clearly all the intrafractional body motion can be accurately quantified. You can see how much the motion. So within 2 minutes, you can see, the lowest point, the highest point, the motion range, and how the patient move. And this is the AlignRT can do capability of just do this kind of tracking. But there is always a correlation of the intrafractional body motion with the motion of the internal organs, target, and OARs. This will remain a future topic for research, and it's easy to track the patient's surface, but for the target inside, we either need the fiducials or continuous tracking, and there's some continuous tracking tool now, especially for pelvic, can use Calypso, Clarity, ultrasound, and to do the continuous tracking. Then it can be compared with AlignRT to see really the correlation of the surface motion to the target motion, but this will remain the further future research. And again, as conclusion, and the intrafractional body motion for large BMI patient, and it's higher in prone. So we recommend to treat the large BMI patient with supine position. So for the prone position, the average motion can be 1.6 centimeters, the intrafractional body motion. And for the normal range BMI patient is highly patient dependent. And the good part is we use AlignRT. We can pre-decide which position is better. So if you have the time and if you don't feel it's too much work ahead, you could take the patient in to just let them to be in the 2 different positions to track to see which one is better. But of course, this is still, and it's just the intrafractional body motion. It doesn't represent anything about the dosimetric kind of advantages, either the small ball or out or not, but still keep in mind. So even you have a perfect, absolutely perfect treatment plan, how this plan can be achieved when you treat the patient, this is always a question. So if you prefer patient doesn't move much, you know what exactly you delivered. In my opinion, I think you will choose the one has less body motion if you don't do any suppression. But during pelvic treatment, we normally don't do anyway. So the good part is AlignRT. We have this tool, so we can do our management before we even go to the CT sim, before we go to the treatment planning process. So as a conclusion, we say AlignRT is a very powerful tool for assessing intrafractional body motion, not just pelvic. It can be any body part, any treatment site. Thank you. This is the closet. I think the data shows if they're comfortable, they would not move.
I'm curious as to if you just ask the patient whether they're more comfortable one way or the other, would that be as correlated with doing this test?
Yeah, we didn't ask, but generally speaking, patient would say, and with that belly board, it's not that comfortable, and no matter which position is less motion.
Hi, thanks. That was a really interesting talk. I was just interested in your patient prep. So do you as standard have a full bladder? And if you do, I would imagine it's more uncomfortable to lie prone on a full bladder if you are smaller than if you've got a higher BMI. Has anybody looked at sort of bladder volume?
For this study, when we did it, and we didn't direct the patient to say you should have the low bladder and you empty your bladder. We didn't do that, and I did see because actually this study was two parts. One part is compared with the CT on rail, and it's very clear some day the patients have very high bladder feel and the rectal feeling also. The rectal feeling can be huge different. So for bladder, you can direct the patient to empty the bladder or make a full bladder, but for rectum, it's really hard. So we didn't do that, but yes, there's some difference.
I just want to point out that the presentation you gave, which was very good, does not match your abstract, which is about breasts and tangents and DIBH. And I'm wondering if perhaps somebody else's abstract was switched with yours.
Ooh.
In the book, your abstract underneath your presentation, it talks about tangents and breasts and DIBH.
Oh.
But the presentation you're giving, which is very good, doesn't match your abstract. And I'm kind of wondering if perhaps your abstract was switched with somebody else's in here.
No, actually, it's originally, I submit two.
Oh, okay. Thank you.
And then I think Robin decided finally to put this one. And I think there was the other talk closer to that one, but I thought that was the case. But
okay, that explains it. Thank you.
Thank you for pointing that out.
Thank you.
Thank you.